Imagine this. A single towering spacecraft streaking across the blackness of space, carrying within it not just a crew of trained astronauts, but the hopes of an entire planet. No orbital assembly. No complex docking maneuvers. Just one massive rocket, one ambitious trajectory, and one historic destination, Mars. This isn't science fiction. This is SpaceX's real-life plan. But the burning question remains, could SpaceX land on Mars in one go? It's a vision so bold it almost seems reckless. But if anyone has the audacity to try it, it's Elon Musk. SpaceX's flagship for this mission is the Starship. It's a name we've heard repeatedly, but few realize just how radical its design really is. At nearly 120 meters tall when paired with its super-heavy booster, this spacecraft is taller than the Statue of Liberty. Built entirely out of stainless steel, the Starship is intended to be fully reusable. But more importantly, it's designed to do what no other spacecraft has ever done: carry a full crew and cargo load to the surface of Mars without needing to refuel in space, stop at a space station, or rely on any outside help. This one-go approach would revolutionize interplanetary travel. Traditionally, missions to Mars involve multiple launches, in-orbit assembly, and intricate timing. They use modular strategies, building up a mission piece by piece in Earth orbit before finally committing to the transfer burn toward Mars. But SpaceX wants to throw that out the airlock. Their vision is a seamless journey from Earth to Mars with a single launch. But that raises some tough engineering and logistical questions. First, let's talk about energy. Getting a payload to low Earth orbit is already incredibly difficult. Every kilogram of mass requires an enormous amount of fuel to escape Earth's gravity. Now consider pushing that same mass all the way to Mars. The energy requirement increases drastically. A single launch solution means that Starship must carry all the fuel it needs for the transmartian injection, the landing, and perhaps even the return trip, unless it plans to refuel on Mars. That's a tall order. And the mass of the fuel itself adds to the challenge. It's a vicious cycle. To solve this, SpaceX has proposed in-orbit refueling. The idea is that Starship will first reach orbit, then other starships, acting as tankers, will launch to dock with the main vessel and transfer liquid methane and liquid oxygen into its tanks. Once fully fueled, the Mars-bound Starship will fire its engines and begin the interplanetary journey. So in a sense, SpaceX's version of a one-go mission still involves multiple launches. But from the public's point of view, it looks like one seamless trip. One crew, one ship, and one destination. But even assuming refueling works flawlessly, the journey to Mars is long. Around 8 to 9 months depending on planetary alignment. During that time, the crew will face isolation, radiation, zero gravity, and psychological stress. The spacecraft must support life continuously for nearly a year. This is where Starship's size becomes an advantage. With a spacious interior, it can accommodate storage decks, hygiene stations, sleeping quarters, and even communal lounges. Compared to Apollo or Soyuz capsules, this will feel like a luxury cruise. However, all the comfort in the world won't matter if the spacecraft can't land safely. Mars' atmosphere is about 1% the density of Earth's. It's too thin to rely on parachutes alone, but thick enough to generate significant aerodynamic forces. Most robotic missions have used a combination of heat shields, parachutes, retro rockets, and even inflatable airbags to cushion their landings. SpaceX wants Starship to use a dramatic belly flop maneuver. As it approaches Mars, the ship turns horizontal to increase drag and slow down. Then, just before touchdown, it flips vertically and fires its engines to make a propulsive landing on its tail. This maneuver has been tested multiple times on Earth, with varying degrees of success. In 2021, Starship SN-15 successfully landed after performing this sequence. But Earth isn't Mars. There's no real way to test Mars landings under Martian gravity and atmosphere until you actually go there. That makes the first mission an enormous risk. There's also the issue of precision. Mars is a big place, but landing in the wrong spot could mean missing vital resources like water ice, or being too far from the planned colony site. SpaceX will need pinpoint accuracy, and the technology to guide such a massive vehicle through the chaotic descent phase is still being refined. Even a few kilometers off target could be disastrous. Then comes the question of redundancy. Traditional NASA missions include backup systems for nearly everything. They plan for failures. If SpaceX sends one ship and something goes wrong, there's no backup. That crew is stranded. Even Apollo missions had a command module in orbit ready to return the astronauts. SpaceX's plan is riskier by nature, and Elon Musk himself has admitted that early Mars missions may result in fatalities. Still, SpaceX is moving forward. They've already begun building prototypes of Starship and testing them in Boca Chica, Texas. The hardware is real. The ambition is real. But the timeline? That's a bit fuzzy. Musk initially said 2024 for a Mars mission, then 2026. Most experts agree that the first crewed Starship won't reach Mars until at least the early 2030s. That gives time to refine the design, run more tests, and work out the bugs. But it also gives time for critics to sharpen their arguments. Let's consider the psychological element here. Sending humans to Mars is not just a technical challenge, it's an emotional one. There's a profound isolation that comes with being 225 million kilometers from Earth. No rescue mission. No immediate help. Delayed communication. You're truly on your own. And doing that with one ship on the first try is like jumping out of a plane with a parachute no one has ever tested. Of course, none of this means the plan is impossible. Bold visions require bold risks. If SpaceX can develop reliable in-orbit refueling, if they can perfect the belly flop landing, and if they can keep humans alive for a year in deep space, then yes, they could land on Mars in one go. But every one of those ifs carries enormous weight. And even then, landing is just the beginning. Once the crew arrives, they'll need to survive, thrive, and build the foundation for a future civilization. So, is it possible? Technically, yes. But is it likely anytime soon? That's another story. SpaceX may indeed reach Mars in one go. But whether that one trip will be a triumphant landing or a cautionary tale will depend on how much they prepare for the unknowns. And space, especially the red planet, is full of them. In Part 2, we'll explore what happens after the landing. How will Starship function as a long-term habitat? What will the crew eat, drink, and breathe? And how will they launch back to Earth? Stay tuned for the second half of this journey into humanity's next giant leap. Alright, let's assume the unthinkable has just happened. After months in deep space, through radiation belts, micrometeorite threats, and psychological pressure, the SpaceX Starship actually touches down on the Martian surface. In one go. No refueling depots, no intermediate stops, just a direct shot from Earth to Mars. The red dust swirls around the landing legs as the engines shut down. A new chapter for humanity begins. But as the engines cool and the silence of Mars takes over, a bigger question looms. What now? The first few minutes after landing are mission critical. Remember, Mars isn't forgiving. Its gravity is about 1/3 that of Earth, and the atmosphere is incredibly thin, less than 1% the density of Earth's atmosphere. That means thermal management, airlock integrity, and landing gear reliability are all under intense stress. A small miscalculation in the landing sequence could lead to a hard impact, and once you're down, there's no quick fix or return flight. So SpaceX would have to ensure the Starship isn't just a rocket. It's a fully operational habitat, ready to support life immediately. Initial steps would likely involve a complete systems check. Crew members would begin by running diagnostics on oxygen, power, communication, and thermal control systems. If any one of these fails, the mission is compromised. Imagine traveling 54 million kilometers just to find out the heater isn't working. A basic atmospheric circulation system must engage instantly to regulate temperatures and distribute breathable air. Martian surface temperatures can swing from -20 to -100 degrees Celsius within hours, and electronics are not a fan of that. Neither are humans. So let's talk life support. The Starship must carry its own oxygen regeneration system. NASA and SpaceX are both exploring technologies like MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It extracts oxygen from Mars' CO2-heavy atmosphere through electrolysis. While the prototype on board the Perseverance rover was just the size of a toaster, scaling this tech up for 20 humans is a monumental challenge. It would need to generate enough oxygen for breathing, backup reserves, and possibly for future fuel synthesis. And then there's water. We can't overstate how critical water is. Not just for drinking but also for hygiene, food preparation, and electrolysis-based fuel production. One option is to bring a full supply from Earth, but that adds enormous weight. More likely, SpaceX will rely on a combination of recycled water from the crew and in-situ resource utilization. That means finding and mining Martian ice. Yes, water ice does exist under the surface, particularly at mid and high latitudes. But reaching and extracting it? That's a different beast altogether. They'd need drills, filtration systems, and a lot of power, which brings us to the next point. Power generation on Mars is not just about solar panels. Sure, SpaceX will install high-efficiency solar arrays as soon as they land, but Martian dust storms can last weeks, even months. During that time, solar efficiency drops dramatically. So redundancy is key. NASA has been working on small nuclear fission reactors like the Kilopower project, which can provide consistent energy regardless of weather conditions. If SpaceX hopes to maintain reliable power, some kind of compact, low-maintenance nuclear system may be essential. Now let's get into crew logistics. After months in zero gravity, astronauts won't just jump out of the Starship like a scene from a sci-fi film. Their muscles will have atrophied, bones weakened, and sense of balance severely disrupted. Even Martian gravity, though weaker than Earth's, will feel overwhelming. Initial excursions outside the ship will likely be limited to brief, carefully planned EVAs. These early surface operations would include soil sampling, sensor deployment, and habitat perimeter inspections. And speaking of the habitat, let's not assume Starship is the final living space. While it can act as a temporary habitat, it's not optimized for long-term Martian living. The interior will be cramped, with limited privacy, shared facilities, and an environment more akin to a submarine than a home. SpaceX will need to deploy inflatable habitats or construct semi-permanent modules using Martian regolith as building material. NASA has been testing 3D printing techniques using simulated regolith, and if viable, this could be a game changer. But how would we even get that construction started? Automation. Robots will be the frontline workers in the first phase of Martian colonization. Drones, rovers, and automated printers will likely be sent ahead or alongside the crew. Their mission: scout the area, build basic infrastructure, lay out power lines, set up solar panels, and maybe even start mining ice. These machines won't just support the crew, they'll ensure survival. Now let's talk communication. Mars is not close. Depending on orbital positions, the delay in sending a message from Mars to Earth can be anywhere from 4 to 24 minutes. That means real-time communication is impossible. There is no calling Houston for help during an emergency. So, AI systems on board need to be robust, capable of diagnosing problems, offering solutions, and even executing commands independently. Autonomous software isn't just a luxury, it's a lifeline. Food, obviously, is another issue. In the short term, the crew will survive on prepackaged meals, freeze-dried, vacuum-sealed, and meticulously calorie-counted. But for any mission extending beyond a few months, Martian agriculture becomes a must. NASA has been experimenting with growing crops in simulated Martian soil. While the soil is toxic in its raw form due to perchlorates, it can be treated and mixed with organic material. Hydroponics and aeroponics also offer promising avenues. Imagine a small greenhouse inside a Starship module, a splash of green in a sea of red. Psychological well-being is perhaps the most underestimated challenge. Mars is a lonely place. There's no blue sky, no ocean waves, no birdsong. Just dust, rocks, and silence. Isolation and confinement can break even the strongest minds. That's why social dynamics, personal space, and recreation facilities are absolutely essential. The Starship would need VR systems, books, music, even artificial windows displaying Earth scenes to maintain mental health. And let's not forget regular contact with family back home, even if it's delayed. Security is another consideration. We're talking about surviving in an environment that is constantly trying to kill you. The Starship will need radiation shielding, micrometeorite armor, and backup systems for every essential process. Even a tiny air leak or computer glitch could become fatal. Redundancy will be the backbone of Martian safety. Double oxygen tanks, double water purifiers, double everything. Because on Mars, there's no margin for error. Assuming all of this is in place, the mission transitions from survival to science. Mars isn't just a destination, it's a treasure chest of knowledge. Geologists would look for ancient riverbeds and lake deposits to study the planet's watery past. Biologists would search for microbial life beneath the surface. Engineers would test how Mars affects materials, machines, and human physiology over long durations. Every minute on Mars could yield data that transforms our understanding of the solar system. And then comes the question: do we stay or do we return? Elon Musk's long-term vision involves permanent colonization. That means developing a sustainable fuel production method on Mars itself. The plan is to use the Sabatier reaction, a chemical process that combines carbon dioxide from the Martian atmosphere with hydrogen from water to produce methane and oxygen. These are the exact components needed for Starship's Raptor engines. If this works at scale, it means the return journey is possible without carrying return fuel from Earth. That changes everything. Let's imagine for a moment this all works out. The water is harvested, oxygen generated, methane synthesized, solar power stable, food is growing, and the crew is thriving. Then comes the real test: scaling up. One starship can carry 20 to 100 people depending on how comfortable or cruel you want to be. But if we're talking about a self-sufficient Martian base or even a colony, we need dozens, maybe hundreds of starships making the trip. Each one will bring equipment, habitats, specialists, and new technologies. And yes, the cost is enormous. Launching one starship may eventually drop below $10 million according to Musk, but outfitting it for a Mars mission adds hundreds of millions more. Multiply that by the number of ships needed and we're talking about a multi-trillion-dollar endeavor. But what's the alternative? Stay confined to Earth, hoping no asteroid climate collapse, or global war resets our civilization. Colonizing Mars is the ultimate backup plan. Not just for one nation but for humanity itself. So, could SpaceX land on Mars in one go? Technically yes. But that's just the start. The real challenge begins after touchdown. Sustaining life, producing fuel, managing psychological health, and building infrastructure are all far more complex than just the trip itself. Starship is the vehicle, but the mission is human endurance, innovation, and willpower. Mars isn't going to welcome us with open arms, we have to earn our place there. And in the end, even if we only send a small crew at first, each footprint in the Martian dust is a giant leap for everyone still watching back on Earth. This isn't science fiction anymore. It's happening. And whether you believe it or not, the countdown to Mars has already begun.